Hi everyone, this is Mr. Strickland again, and today we need to talk about frictional forces. Once again, I hope you appreciate my subliminal messaging here, and I hope all of you guys love physics as much as I do. Frictional forces. Okay, what we need to get into is a definition. Friction's that force that acts between moving materials. We're all familiar with friction. It always acts opposite to the direction of an object's motion, or opposite to the applied force if the object isn't moving. So who hasn't tried to drag something along and experienced friction? Frictional force is represented by a symbol. You know, in physics we always have these symbols. So this symbol is pronounced mu. Mu represents the coefficient of friction. The force of friction is proportional to the normal force. This is pretty important. So I'm going to highlight this for you because I want you guys to really understand that this force of friction is proportional to the normal force. So whenever you guys start looking for the force of friction and calculating it, you have to pay attention to the normal force. And you can see your formula there. The force of friction is equal to mu times the normal force. Now there are two kinds of friction. There's static friction, and that's the resistance to motion by a stationary object. Static friction is always greater than kinetic friction. You guys have all experienced this if you've been pushing a car, or if you try to push something heavy like a desk or a filing cabinet. Getting it moving is much more difficult than keeping it moving. And that's static friction that you experience in the beginning when you're trying to get something to move. Kinetic friction is that resistance of motion by a moving object. Objects that are sliding have less friction than stationary objects. And I think you guys all know that intuitively. Now, what we have to learn to use and to calculate sometimes is the coefficient of friction. And the coefficient of static friction is used for objects that are at rest to determine how much force is required to make it begin moving. The coefficient of kinetic friction is used for objects that are moving already across the surface and determining the force that resists the motion. And I think once we start working problems, this will make a little bit more sense. All right, now here are the formulas that you'll need, and you might want to write these down in your composition book. The force of friction is equal to mu times the normal force. So once again, when we're dealing with friction, you have to pay close attention to that normal force. And sometimes if you're given the normal force and the force of friction, sometimes you want to calculate that coefficient. And so then this coefficient of friction, mu, here, can be calculated by dividing the force of friction by the normal force. All right, this is not too bad really. Let's work a sample problem. Here we have an object that has an applied force of 7 newtons to the right. It's experiencing a force of gravity of 15 newtons, which means it has a normal force of 15 newtons. We're going to assume this object's resting on some surface, which is why we're going to be dealing with friction. We can see down here at the bottom that this object's not experiencing any acceleration, and if that's true, then we know the frictional force is going to be 7 newtons opposing it. So we're looking at balanced forces here if there's no acceleration. Now, if we want to calculate what the coefficient of friction is, we might go back and remember what our formula was that you wrote down. Mu is equal to the force of friction divided by the normal force. So we can calculate that. If we want to calculate mu, we're going to divide the force of friction by the normal force. Okay, so mu is going to equal 7 newtons divided by 15 newtons. And mu is going to equal, let me grab my calculator. Calculator here. 7 newtons divided by 15 newtons is equal to 0.466. We'll round that off to 0.47. So mu is equal to 0.47. Now you might notice since this is a ratio of newtons to newtons, that this is a unitless number. So this is one of the few times you get away with having a naked number in my class. Coefficient of friction is just a ratio, so it has no units. I see that wasn't too hard of a problem. Let's work one more, and then I think you guys will be able to work the sample problems you have. Here, let's assume we're looking at another object that's sliding across some surface. We have an applied force of 7 newtons. Since this applied force vector is obviously longer than the frictional vector, we're assuming we're going to have some acceleration. You notice that we have a coefficient of friction that's given. It's 0.6. So all we have to do to calculate the force of friction is remember our formula. The force of friction was equal to mu times the normal force. Alright, so if we have a normal force of 6 newtons, grab our calculator again. We have a normal force of 6 newtons multiplied times coefficient of friction of 0.6. Then we end up with a frictional force of 3.6. So the force of friction would be 3.6 newtons. Let me write this down here for you. The force of friction is equal to 0.6 times 6 newtons. And so the force of friction is equal to 3.6 newtons. Now it's asking for the acceleration. At this point, this problem becomes one much like anything that you've used before. Let me just kind of get where we can see here. The net force on this object is going to be 7 newtons minus 3.6 newtons. So the net force is equal to, grab the calculator one more time, 7 newtons minus 3.6 newtons gives us a net force of 3.4 newtons. Now if we apply Newton's second law, force equals mass times acceleration, and we're trying to solve for acceleration. Acceleration will equal force divided by the mass. So acceleration is 3.4 newtons divided by, let's see, we got to find the mass. All right, so how do we do that? Well, we know the force of gravity. I'm going to erase a little bit here so that we can work. I'll erase a little bit bigger. So if we know what the force of gravity is, then we should be able to find the mass. So F equals mass times acceleration. Alright, if we know the force of gravity, let's see, we're trying to solve for mass, so mass is going to equal force divided by acceleration. So the mass is going to equal 6 newtons divided by 9.8 meters per second squared. So the mass is going to be 6 divided by 9.8, which could give us a mass of 0.61 kilograms, and we can put that over here. So 0.61 kilograms, and now ultimately our acceleration is going to be 3.4 divided by 0.61. 3.4 divided by 0.61 equals 5.57 meters per second squared. Now this is something some of you guys have been leaving out on your homework, because acceleration is a vector quantity and we've got a magnitude of 5.57 meters per second squared. And we need a direction to the right. All right. So anyway, there we go. I hope that didn't look too ugly, bend your brain too much. I'm going to leave it this here. We're going at about 10 minutes, so I'm going to stop the video here, and hopefully you guys can work the assignment that you have for today. And if not, send me some questions on Edmodo, and we'll work on it when I get back to class.